On August the 25th, 1981, the space probe Voyager 2, sent out to study the planets of the solar system, reached the Saturn system. Humanity gained its first chance in history to observe the gas giant up close. The probe captured images of the planet and its rings. As it passed by, it also photographed several moons, including Titan, which appears unusually dark here due to its dense atmosphere that reflects little light. It also captured Tethys and Dione, moons that in these images show up as two faint white dots. But when the spacecraft approached Enceladus, the photos sent back to Earth puzzled scientists. Among them was astronomer Bradford A. Smith, who led the scientific team responsible for operating the Voyager cameras and analyzing the data. Studying these images, he and other specialists noted that the moon did not appear as expected. The data transmitted to Earth made it look as though this world was no more than 1 million years old, as if it had only been formed recently, as opposed to billions of years ago. If you look at the image taken by Voyager from a distance of 74,000 miles, you'll likely see what they meant. The northern hemisphere looks like a typical cosmic graveyard, densely populated with craters, but as your gaze moves towards the equator and further south, the scars from the meteor impacts disappear. In their stead, you'll see smooth plains marked by curious tectonic fractures. In the southern hemisphere, there are no traces testifying of billions of years of bombardment. It's as if there was never a single asteroid impact down there, or some large-scale process continually erases craters that would have formed. Other images from the probe further confirmed this anomaly. NASA specialists proposed an extraordinary hypothesis. What if there is a huge ocean beneath the surface, its geological activity constantly reshaping the landscape? But this idea seemed incredibly bold. This tiny world with no atmosphere lies almost 10 times farther from the Sun than Earth. According to all laws of physics, even if there were any water present, it should have frozen solid billions of years ago. So, where might liquid water have come from? These images and this thermodynamic paradox captured by Voyager 2 later led NASA to develop an ambitious mission: to send the Cassini-Huygens spacecraft back to Saturn to explore the planet and uncover the mystery of Enceladus. The presence of liquid water in such a distant and cold environment would mean more than just a geological anomaly. Scientists go as far to consider it a potential environment for extraterrestrial life. We already know that the smooth southern hemisphere left scientists confused, but a closer analysis of the Voyager images revealed another anomaly related to the moon's geometry. Enceladus has a diameter of just 310 miles. It is so tiny that it could fit entirely within the borders of Arizona. If there was a road built along its equator, traveling at 60 miles an hour would allow you to circle the entire planet in just 16.5 hours. Doing the same around Earth would take more than 17 days, or 415 hours of non-stop travel. Compared to our moon, Enceladus is nearly 7 times smaller and hundreds of times lighter. Astrophysics dictates that objects of this size are rarely perfectly round. They simply lack sufficient gravity to pull their mass into a neat sphere. This is why most small moons within the solar system look like irregular rocky fragments, such as Saturn's moon, Pan, that looks kind of like a dumpling. Take a look at this image relayed by Voyager 2. Here, Enceladus is softly illuminated by light reflected from Saturn. Color aside, pay attention to its shape. Its silhouette appears remarkably smooth and almost perfectly spherical. In the 1980s, this was a major mystery. How could a celestial body with such weak gravity maintain such a perfect shape? This was the first clue. A near-perfect sphere suggested that the moon was not just a chunk of frozen rock. There was something inside that was maintaining this strict structure. However, Voyager 2 sped past, leaving many questions unanswered. We saw the surface, but not the underlying cause of the anomaly. The search for answers had to be paused. 16 years later, in 1997, NASA and ESA launched the Cassini mission, aimed right towards Saturn to investigate further the mystery of its satellite. At the time, scientists had no idea of the unique event that would take place during this expedition, nor how much risk would be involved. It took Cassini 7 years to reach Saturn, finally arriving in orbit in late 2004. For the first time since Voyager's flyby in 1981, scientists could observe Enceladus up close, but this time in far greater detail. Over the next 13 years, Cassini orbited Saturn 294 times. Each orbit became a new expedition. It photographed Saturn, its rings, and its moons, but the most remarkable findings came as it approached Enceladus. These unprecedented images allow us to observe this icy body in fine detail. Once again, images showed cracks and fractures, along with striking contrast between one side heavily covered in craters, some reaching up to 22 miles across, and the other side all smooth and bright. This contrast is especially clear in images taken from just 4,000 miles away. Image after image, gigabytes of data. During one flyby, Cassini moved into the moon's night side and captured dramatic images. But then, the mission witnessed an event no one expected, capturing a unique occurrence with its cameras. Backlit by the sun, the horizon revealed enormous and powerful water geysers. The first striking feature was their scale. Against the small moon, they looked enormous. Somehow, in this cold and distant world, there was liquid water. It was as surprising as finding a big boiling lake in the middle of Antarctica. Further study showed that the water was being ejected at speeds of about 800 miles per hour, faster than the speed of sound on Earth. Every second, more than 53 gallons of water were expelled into space. These plumes reached 310 miles in height, so tall that much of the water instantly froze and drifted into the cold vacuum of space. But this was not a rare occurrence. The geysers on Enceladus were continuous, varying in intensity but never stopping, as though this moon was breathing. Even Cassini could not fully capture the scale of things happening out there. In 2023, the James Webb Space Telescope aimed its infrared sensors at Enceladus. The image we received made astrophysicists question whether they should trust their eyes. There was a plume of water vapor extending more than 6,000 miles into space. Leading researchers, including Geronimo Villanueva of NASA's Goddard Space Flight Center, initially thought it was an optical error. A plume nearly 20 times larger than its source seemed beyond any physics we know. These plumes also help form one of Saturn's features, the faint E-ring extending around the planet, the outermost ring of this gas giant. Unlike the dense rings, it's barely perceptible. It's not a solid structure, but a thin cloud of icy particles, sourced from Enceladus. As the water vapor rises from these geysers, it freezes, and some of it is captured by Saturn's gravity. The image captured by Cassini reveals a long tail originating from its south pole. The E-ring is constantly replenished, and without this process, it would have vanished a long time ago, fading into outer space. In essence, the tiny moon of Enceladus contributes material to Saturn's appearance. Meanwhile, anything that hadn't been carried into space falls back onto the surface in the form of snow, covering much of the southern hemisphere in a dense layer of brilliant white. This snow is so white it reflects about 98% of sunlight, compared to about 10% for Earth's moon. This process partly explains the difference between the two hemispheres. Fresh snow continually falls in this region, gradually covering ancient impact scars. Over tens of millions of years, a whole lot of this blinding white snow accumulated on Enceladus. Although powerful, the geyser activity on Enceladus is concentrated in a specific region. During its flybys, Cassini identified their source, an area that's since become known as the Tiger Stripes. In the images, these appear as 4 parallel fractures near the South Pole. At first sight, they might look like crash sites of ancient asteroids, but they are not impact scars. In reality, these are active tectonic faults. That's where the geysers captured by Cassini originate from. Additionally, these fractures are constantly shape-shifting, practically stretched by Saturn's gravity. This image demonstrated how Saturn's influence can widen the cracks or move 2 coastal cracks sideways, similar to tectonic faults in San Andreas, California. Detailed gravity analysis revealed an even more shocking conclusion. The icy crust harbors a global ocean between 6 and 18 miles deep. This finally solved the mystery of the anomalously smooth surface captured in the Voyager images. Continuous water movement, tectonic activity, and fresh snow from the geysers constantly reshape the icy shell, keeping its appearance young, geologically speaking. Recognizing the significance of this discovery, NASA scientists took an extraordinary risk. They altered Cassini's flight path, sending it into a very close dive. On October 28, 2015, the spacecraft passed just 30 miles above the South Pole. For reference, this is about 8 times lower than the orbit of the International Space Station around Earth. But photographing the Enceladus moon was not the only reason for this maneuver. Engineers wanted the spacecraft to directly sample material from the plumes, effectively tasting the ocean of this alien world. And they succeeded. Cassini flew directly through the plume above the Tiger Stripes at the speed of thousands of miles per hour, its scientific instruments getting hit by particles of ice and vapor from the hidden ocean. For the first time in history, spectrometers detected the composition of an extraterrestrial ocean. Water, carbon dioxide, free hydrogen, and complex macromolecular organic compounds. In other words, a full set of biological building blocks. This was a major triumph. Now that we know that there is a warm, active ocean beneath the unusually smooth surface, the key question shifts. What is this subsurface world actually like? Why do scientists consider the possibility of life on Enceladus? And what might life look like if it exists up there? To begin answering these questions, let's make a landing to the surface of Enceladus and see what a unique world we encountered. The view from the surface of Enceladus feels like being inside an endless, empty, sterile white room. This is a world almost devoid of shadows, where the eye struggles to find reference points and the sense of distance quickly fades. Although the sunlight is about 90 times dimmer here than it is on Earth, the surroundings are filled with soft, diffuse light. This is due to the extremely bright, icy dust covering the surface. The South Pole has been coated with this material for millions of years as it falls from the geysers. This icy dust behaves more like dry flour or talc powder than ordinary snow. It does not compact or hold shape and remains very loose. For future explorers, this could be a serious hazard. Gravity out here is only 1% of Earth's. A person in a heavy spacesuit weighing 440 pounds on Earth would weigh only about 4 pounds on Enceladus. If you found yourself on the surface of Enceladus, it would feel close to weightlessness. You might think that being so lightweight, it would be impossible to submerge into the ice dust, but that's not the case. Standing still on one spot for too long would cause a slow sinking into the loose frozen material. A person could gradually sink like in quicksand, with no solid surface to push against. Survival would require constant movement. Near the Tiger Stripes, the disorientation can become unsettling. Just a mile away, powerful jets shoot into the blackness of space. They stream towards Saturn, which hangs over the horizon as an enormous disk. Yet there's no sound. Enceladus has no atmosphere, so even these grand eruptions occur in total silence. You wouldn't hear the geysers roaring. The only sensation would be a low, rhythmic vibration underfoot. As for temperatures, they're just as extreme. At the cold equator, the surface remains at about -200 degrees Celsius. Around fractures that let vapors escape, temperatures rise to about -93 degrees Celsius, almost twice as warm as the surrounding terrain. This is due to the global ocean beneath the ice shell, which is about 12 to 18 miles thick. In the Tiger Stripes region, the ice is much thinner, about 3 miles, similar to certain regions of Antarctic ice. But where does this ocean get the energy to remain liquid? And does this point to a potential for life? An icy sphere the size of Great Britain, located nearly 900 million miles from the Sun. Even without specialized knowledge, it seems obvious that at a distance like this, any water should have frozen solid billions of years ago. In spite of it all, there is an ocean here. According to our scientists, this phenomenon owes itself to gravity, which is effectively pulling the Moon apart from within. Enceladus is caught between powerful forces. On one side, it's pulled by the colossal gravity of Saturn. On the other hand, its orbit is disturbed by the nearby moon Dione. This creates a resonance that stretches its orbit into an oval. Every 33 hours, as it orbits Saturn, gravitational forces compress and stretch its interior, like kneading a piece of clay repeatedly until it warms up due to constant friction. Scientists call this process tidal heating. This mechanism acts like a planetary heater, preventing the water from freezing. But this energy source affects more than just ice. The most remarkable processes occur at the ocean floor. The Moon's core is not a solid rock. It's porous, like a giant stone sponge. Under immense pressure, water seeps deep into this heated interior. Calculations suggest that it can reach temperatures of about 90 degrees Celsius. It absorbs minerals and is then expelled back up. Researchers confirmed the presence of hydrothermal vents on the ocean floor. This is essentially a chemical kitchen, hidden in total darkness, where inorganic material interacts with internal heat, creating conditions suitable for complex reactions. Analysis of the geyser plumes performed by the scientists at ESA shows that the ocean is basically a big broth rich in chemicals. Cassini spectrometers detected nitrogen, methane, carbon dioxide, and free hydrogen. The presence of hydrogen indicates that these hydrothermal systems are active even now. An even more striking discovery followed. Complex organic molecules were found in the water. These carbon chains are the basic building blocks of all known life on Earth. The thick ice shell protects the ocean from harmful radiation, while the heated core provides a steady energy source. Scientists consider this an ideal environment for the origin of life. This leads to an intriguing question. If this alien laboratory has operated for billions of years, what might have developed there as a result of its endless experiments in the dark? The ocean of Enceladus operates under very different rules than Earth's oceans. There's no sunlight and no photosynthesis. It's ruled by total darkness, and energy comes from below, from the heated core. Naturally, scientists don't expect to find complex organisms like the green aliens we see in fiction, but life forms similar to extremophiles on Earth that can survive in harsh environments. The most likely candidates are methanogens, microbes that do not require oxygen. They consume hydrogen and carbon dioxide, producing methane as a byproduct. The presence of all these ingredients in the geyser plumes may not be a coincidence. It resembles a complete set of resources for a potential ecosystem. like a fully stocked buffet. While microbes are the primary focus of Earth scientists, they don't entirely rule out the more radical scenario. What if, over billions of years, stable conditions in the deep dark ocean might allow complex multicellular organisms to develop? As you know, the chances of that are pretty low, but it's still within the realm of possibility. Such organisms would likely differ significantly from anything residing in Earth's oceans. One shared feature might be a streamlined body shape, since the principles of fluid dynamics apply everywhere in the universe. But they would almost certainly lack vision organs. In a world where no light penetrates the thick ice, eyes would serve no purpose and therefore would be a waste of energy in the evolutionary sense. To survive, hunt, and navigate this eternal darkness, they might rely on electrical sensing, echolocation, or highly sensitive chemical detection instead. The situation on Enceladus is similar to Europa, its sister moon in the Jupiter system. Europa also harbors a subsurface ocean, and NASA's Europa Clipper mission is traveling there as we speak. The main objective of this $5 billion spacecraft is to assess Europa's habitability. However, Enceladus has a significant advantage, a space cheat code of sorts. On Europa, reaching the ocean may require drilling through about 12 miles of ice. On the other hand, Enceladus ejects materials from its ocean straight into space. There's no need to drill. The spacecraft only has to pass through the plumes. That's how the concept behind the Enceladus Orbilander mission developed. It's a next-generation flagship mission, a large scientific fortress weighing over 13,000 pounds. The plan for it is ambitious. First, the spacecraft will orbit the moon, repeatedly diving through the plumes for several years, and will eventually land near the tiger stripes. But there's more. The most exciting detail regarding this mission is that we may find evidence of extraterrestrial life before the spacecraft touches down on the surface. Enceladus Orbilander would carry DNA analyzers and high-resolution mass spectrometers on board. Passing through the plumes at an altitude of about 18 miles, the spacecraft would collect droplets from the primal ocean. If living cells, or even fragments, are present, the instruments could detect them while on the move. This means answers could be obtained directly from space. Even if we discover no living organisms, scientists would still look for signs of life. ESA scientists are confident in stating that life tends to create order. If samples show specific patterns in amino acids or particular fatty acid chains, this could serve as an ironclad alibi that there is something living beneath the ice.